Hi everyone. We're going to be starting part 3 of chapter 1, which is about psychology experiments and experimentation in general. I really like this section, one, because I'm an experimental psychologist and this is my training, but also because it's a really interesting window into how research is actually performed, some of the pitfalls, some of the benefits, and some of the controls we put in place to make sure that when we're talking about our results, we have a really good basis to stand on. So first off, we're going to be talking about what an experiment is. We use that word a whole lot in popular media, but the actual definition is that an experiment is a formal trial undertaken to confirm or disconfirm a hypothesis about cause and effect. So we want to investigate a causal relationship between a stimulus and a response. So that takes 3 steps. The first is to directly vary a condition that you think that may affect that behavior. We want to create 2 or more groups of participants, a control and an experimental group. We're going to talk a lot more about this. And then we're going to record whether the varying condition has any effect on behavior. So think about something simple. I like to use the example of baking chocolate chip cookies. So you want to see how maybe changing one feature of the cookie recipe can change the outcome of the cookies for better or for worse. So you may decide for step 1 that you think instead of using white sugar, you're going to use brown sugar. You think maybe that'll add a little bit more caramelly and toasty notes. So you want to change the sugar. But you also want to have, as step 2 says, create 2 or more groups of participants. You don't just want to look at the recipe and then make it with brown sugar instead of white sugar. If you're really going to do this formally, you want to make the recipe as stated in the directions with the white sugar, and then make a second batch with the brown sugar. And then, after you're done baking them, you eat them and you decide which one had the effect on the behavior of the cookie that you liked the best. So maybe the white sugar was better, maybe the brown sugar was better, but you actually now have gone and done that experiment. So subjects, our experimental subjects are the individuals, or in this case, typically humans or animals that are part of our experiment. Typically, we refer to humans in our experiments as participants. Sometimes you see them listed as subjects, and we're investigating their behavior. Nope, go away. All right. When it comes to human subjects, we like to say the word participants. It's a little bit nicer. We say participants because it sounds like, okay, they participated in our experiment. They weren't subjected to our experiment. And especially after we've talked about research ethics and things that have gone wrong in the past, it's important that the participants are actively willing to be a part of our experiment and not just being told that they have to be a part of it. And they're going to create both our experimental and our control group. Also with experiments, we have variables. Variables are any condition that changes or can be made to change. It could be a measurement, an event, or a state that may vary. Going back to our cookie example, a variable could be the way we mix the cookies, the ingredients we use, the time or temperature that we use to bake the cookies, the pan. It could be a whole variety of factors. Those are a lot of different variables. Independent variables is a condition that's being investigated as the possible cause of some change in the behavior. So we think that maybe manipulating the ingredients of the cookie will change the cookie. So we want to that we're going to be manipulating that. So that's our independent variable. Our dependent variable is the condition that's affected by the independent variable. So in this case, it'd be the flavor or the texture or the color of the cookies. It's the outcome. So the dependent variable depends on the effects of the independent variable. So by changing the sugar from white to brown, the recipe or the flavor of the cookies will change, and that's dependent on the type of sugar we used. So the best way to remember this is the independent variable is what's manipulated, and the dependent variable is what is measured. Extraneous variables are conditions or factors that could change and should be excluded as much as possible from influencing the outcome of our experiment. We have to control these things. Now, when we're talking about our cookie example, let's say we're making our 2 batches of cookies, one with the white sugar, one with the brown sugar. but somewhere in between, our mixer stops working. You made the ones with the white sugar, and now you're gonna go make the ones with the brown sugar, and so our mixer's not working, so you try to do it by hand. But if you know anything about baking, if you don't mix the batter exactly the same way, then the texture may change. So that would be something you'd want to control. You'd maybe want to go out and go buy the exact same mixer or start over and make both by hand. You got to make sure you control these extraneous variables. Otherwise, you could have unintended consequences and other things that can be affecting your dependent variable, and then you won't know what's actually causing the change. So now there's some quick examples. So if a researcher wants to know if narcissistic individuals have more mirrors in their home than non-narcissists, we have to think about what is being manipulated and then what is being measured. So I'm going to give you this one right here. So if our dependent variable is being measured, what is our measurement? So probably the number of mirrors, right? And then your independent variable is the level of narcissism. So the high on the narcissism scale or lower on the narcissism scale. Another one here, the effects of alcohol on reaction time. What's being manipulated, and then what's being measured. So manipulation would be the amount of alcohol, which should be measured in number of ounces that the person has had. So 0 ounces, 3 ounces versus 6 ounces. And then we're measuring the subjects or the participants' reaction times, probably getting slower as they're drinking more. Exposure to violent media predicts subsequent violent behavior in children. So in this case, what is being manipulated? What is being measured? So if you were going to run this study, what would you manipulate? The exposure to the violent media. So how many hours of violent media the child watches, maybe violent games that they play, or number of violent incidences that they see. And then we're measuring the child's violent behavior. So the number of times they hit their siblings or their friends, or maybe they act out the violent behaviors. Okay, so I hope you understand that at this point. Good job, and we're going to be moving on. So in our experiment, we have to have what's called a control group. The control group is the group of subjects that's exposed to all the experimental conditions and variables except for that independent variable. So we would always have the group that goes through the same procedures, they go through the same lab setup, they meet the same people, they're given the same instructions, but whatever that one thing that you're manipulating is, you just don't do that thing. So for example, the cookies, we could have the cookies that are our control cookies are the cookies that are done to the recipe as written. So the ones with the white sugar. And they get everything else. They get the same mixing, they get the same butter, they get the same chocolate chips, they get the same flour, same temperature, same pan, same oven, everything. They go through everything except for the change in the sugar. But how do we know if we have, say, we're doing an experiment where we're looking at IQ. So maybe students who take intro psychology perform better on the SAT than students who didn't. Maybe we just ended up having all the students who are really smart take the psychology class because they're smart and they wanted to take psychology, right? So we have to make sure that people in the one group aren't just worse than people who are in the other group. And to do this with humans or animals, we use what's called random assignment. So we'll use chance, either flipping a coin, a random number table, just who walks in, A and B, and we assign the subjects to the experimental or the control groups. We just want to make sure that, we're not somehow selecting our groups to be different. Maybe if you're looking at giving a test, if you gave, test form A to the people in the front of the room and test form B to the people in the back of the room, and you say, oh, A is definitely a much easier test than test B, maybe it's because the people who tend to sit in the front of the class or pay more attention and are maybe a little bit more studious. So I say this to the students who are sitting in the back of the classroom. And then we have to evaluate our results. And to do this, after we collect our data, we have to run a statistical test. And what we're looking for in this test is what's called statistically significant results. These are results of our experiment that would not happen by chance alone. Now, There's a variety of different statistical tests that we're not going to go into great detail about at this point, and not a whole lot in this class. This isn't a stats class. But what you do is you go through the procedures of the test and you do the equations, and at the end you get a number. And dependent on the number of subjects or depending on the type of test, you get a number at the end. That's your result. And what you want to see is that that number has a less than 5% chance of happening just randomly in the universe. So if you were to flip a penny or flip a quarter and you got heads every single time, you say you flipped it 10 times. That's unlikely. But there is a chance in the wackiness of the universe that that can happen, that you would flip a coin 10 times and it would always land on heads. But as statisticians, we want to make sure that that's a less than 5% chance. So again, if you're giving your test, test form A and test form B, you want to make sure there's a less than 5% chance that these things would, the difference between the tests would just happen randomly. And so that 5% is like essentially the amount that people in psychology have agreed is a good amount. And this actually works across a variety of disciplines, not just psychology, but 5% chance is pretty darn sure. And we call that our alpha level. Alpha is equal to 0.05. So our results from our test need to be less than 0.05. And what's what we call our p-value. So that 0.05 represents the 5% chance, and we want our p-value to be less than that. This makes it more likely that our experiment will be replicated by future studies that are doing the exact same thing. We want to make sure that when we're making these claims about our research, that the likelihood of this just happening randomly and not through actual effect is very low. And then after a variety of researchers have actually done the experiment, collected their data, ran their analyses, and published the results, other researchers do what's called a meta-analysis. This is when they combine data and results from a variety of different studies on the same subject, they put them together, and then they use a statistical technique that can combine all this data and create more powerful results. This is what we do with a lot of drug studies, studies on vaccines, studies on the effect of common illnesses on people. And the thing is that when it comes to running an experiment in your own house or in your own lab, it can be very timely and costly. But if a bunch of people from all over the world are doing it, even if they're doing it in slightly different ways, we can combine these results in what's called a meta-analysis. So for an example, vaccines. There at this point has been a variety of meta-analyses done that look at populations all over the world, especially in North America and in Europe, and they've looked to see the safety of the vaccines and that there is no link to autism. And they've been doing this with millions upon millions of children's data collected in a variety of different doctors' offices and hospitals and clinics all over the world. And they've been able to show that there is no link to any detrimental effects when it comes to any of the vaccines that are commonly given to children around the world, which is pretty amazing. There's no one research lab or university that could collect 25 million data points. But with meta-analyses, they've been able to combine the results from all over the world, different countries, different labs, different hospitals, and to put those together in this common statistical technique. Now, when we're doing a study, we have to be careful of a couple things, namely placebo effect and the self-fulfilling prophecy. So let's say we want to test a weight loss pill. And let's say we have 50 participants. We give 25 of them the weight loss pill and the other 25 get nothing. What problems do you see with this? So when you're giving someone a pill, their mind says, I'm taking this, so it's probably going to have some sort of effect. These doctors and scientists have designed this pill to help me lose weight. So because I'm taking the pill, I know I'm in this study and I should be losing weight. So sometimes people, when they're given a medication, they will actually slightly alter their behavior, knowingly or unknowingly, to fit what they think is supposed to happen. So people who are taking a weight loss pill, they may think, oh, I'm not as hungry as I usually am. Or, man, I have more energy. I'm going to go exercise a little bit more. And they just maybe feel more confident about themselves. And over time, that can actually affect how much weight they really lose. So it has nothing to do with the actual pill. It could be what they call a placebo pill, or a pill that it has absolutely no active ingredient in it, usually just like baking soda or sugar pill, they call it. And it's actually not doing anything in their body, but their mind is making them think, I should be losing some weight, and they begin to actually lose the weight. So when you're doing a study like this, the best practices is that the participants who are taking the pill and the person who's giving them the pill do not know who has the pill and who has the fake pill called the placebo pill. This controls for our placebo effect. So part of this problem is what's called the research participant bias. So the changes in the behavior of the study participants could be caused by unintended influences of their own expectations. So first of all, if people are taking part in a weight loss pill study, they probably volunteered for that study. They probably want to lose weight. They're motivated to lose weight. They're interested in helping. Also, people who enroll in studies typically want to be good subjects. They want to be good participants in your study. They want to see the effect, and they want you to see the effect. So they'll slightly alter their behavior. They'll alter their answers. So that's what we call the research participant bias. They actually want to do well, so they change their behavior. And this can cause the placebo effect, which is changes in behavior due to the participant's expectations of that drug or the treatment is going to have some effect. And the placebo itself is any inactive substance given to the participant in place of a drug in psychological research or in medical research, or by a physician who wants to treat the complaint by suggestion. If you've ever, seen like like with little kids, they'll have like Monster spray, and it's like a can, like aerosol spray. It's actually air freshener, but the mom or dad will put a label on it that says Monster spray. So when the kid at night is saying, "Oh, mom, I'm so scared of the monsters under my bed," they spray the air freshener, and they say, "Okay, that's the monster spray. It'll keep the monsters away." And the kid goes to bed happily, thinking the monsters are now gone. That's part of the placebo effect, and the placebo is that air freshener that's just labeled and using the power of suggestion to tell the child that the monsters are gone. There's a really great video linked below by Ted Ed about the placebo effect that I highly suggest that you watch. There's also another one from Grey's Anatomy. I know you guys love Grey's Anatomy, where Derek is running an Alzheimer's trial that you should check out, and you'll see how the placebo effect may play a role in there. And then we're going to talk a little bit more about single and double blind experiments, and you'll see that in this as well. And there's also a really good one from National Geographic linked below about Parkinson's research that I'm going to talk about a little bit more later. So I just mentioned this, a single blind experiment. This is an arrangement in which participants will remain unaware of whether they're in the experimental group or the control group. These people are given the same instructions. They get a sugar pill or a saline injection. They're also not blind, to the hypothesis being tested in many cases. So they may not actually know what type of experiment they're in. So for an example, a research study that I used to participate as a researcher in would ask the subjects these adults to come in, and they would have to watch a series of flashing shapes. So a shape would come up every 1 second, and it would be paired with a phoneme or a sound. So la, re, ba, ta, di, do, things like that. And every time the same shape and sound was made in a row, they had to click the space bar. So the people are so focused on doing this task of hitting the space bar, that's not actually what we were testing. Afterwards, the instructions would come up on the screen, and it would say, what you just saw was actually an alien language. So now we're going to ask you to rewatch a couple of these little shape sound pairings that come up at the same speed. If it's something that's familiar to you, hit the key on the right, and if it's unfamiliar to you, hit the key on the left. People would be like, I have no idea. I've never seen this. I didn't study that. And it was good because we distracted them. And people, when you show them the things coming up again, really rapid fire, they were actually statistically significantly more likely than chance to hit the correct answer of yes, this is part of the language I saw, or no. So they were blind to the hypothesis that was being tested about this language learning hypothesis because we distracted them with a different task. But the same thing goes back to being given instructions. You want to give people the exact same instructions. You don't want to tip them off that they may be in a placebo group or that they're in the experimental group getting the medication. And you want to make the pills look the same. They even do this with injections, so injected medications or painkillers. They even go as far as to give fake surgeries in certain cases in order to really fool the patient. And if you watch the Grey's Anatomy video or the National Geographic video linked below about Parkinson's, you're going to see them doing what they call sham surgeries, fake surgeries to these people, where they're doing every single thing except for maybe turning on the device or injecting the active ingredient at the very end. But everything else is exactly the same. I'm going to talk about why in just a second. So changes in the participant's behavior could be caused by unintended influences of a researcher's actions. If the researcher knows who's in the experimental group, they may influence their answers. They may ask questions differently. They may give instructions a little more thoroughly or less thoroughly. They may record data a little bit differently. This goes into what's called the self-fulfilling prophecy. This is a prediction that we make that prompts people to act in ways that make the prediction come true. This is essentially what happens with superstitions. We predict that if we wear our lucky socks for a test, that we're going to do better, and that increases our confidence, and then we do better on the test, and we're like, oh man, our lucky socks worked. So that self-fulfilling prophecy plays a huge role in how well we do. So it's best if the researcher is blind to which participant is in which part of the experiment. Same thing with the participant. We want to make sure the participant is blind as well as the researcher, and that is what we call a double-blind experiment. That's the arrangement in which both the participants and the experimenters are unaware whether the participant is in the experimental group or in the control group, including who was administered the drug or the placebo. So please go in, watch the Grey's Anatomy clip, and you'll see how they are blind until the moment when they inject the either the saline or they inject the active ingredient into the person's brain in the Alzheimer's trial. Although technically, because you'll see in there, the experimenters who are talking to the patients before and afterwards are being given, they're seeing whether the person got a placebo or the active agent in the moment of the surgery. They are technically no longer blind to the experiment. But TV magic, you couldn't have that many doctors in the show. Sorry, my dog just howled. Bruce, you okay? So they also need to be blind. If you've seen the show House, there's a really good example of this in House. There's two characters. There's the girl whose name is 13. She has what's called Huntington's disease, which we'll talk about a little bit in chapter 3. And then her boyfriend, who's also a doctor there, his name is Foreman, she's in a drug trial for her Huntington's disease. And she's supposed to be in this double-blind trial. And he's helping her out. It's an IV medication, so he goes and he hooks her up to the IV, and then he goes up to the nurse's station to chat with the nurse, and the nurse makes his offhand comment. She's like, man, the medication smells really bad, even through the IV bag. And then he realizes, wow, what I just hooked up my girlfriend to doesn't have a smell, so therefore she must be in the placebo group. He now has made it so that it's not a double-blind experiment. Now, of course, because it's TV and, doctors don't have ethics and aren't reprimanded for not having ethics on TV, he goes and he switches out her medication, which is a placebo, for the active agent medication. And then he gets in trouble but doesn't get fired. It's a whole thing. You should watch the show, though. So there's other non-experimental research methods that we can do because we can't always do a true experiment. As you can imagine, we can't always put people into different groups. We can't always give people medications, especially if they really need treatment or it's something that maybe be harmful to them. So experimental methods are the gold standard for investigating behavior or changes in people's behavior through controlled experimentation, but it's not always possible. So for an example, if you want to see the effects of alcohol on developing fetuses, I can't ask mothers to drink doses of alcohol because we do know that alcohol has a toxic effect on fetuses. But we know that because we know people who drink a lot during pregnancy, their fetuses, their children have bad outcomes. We can't try to figure out exactly what's the safe amount or when the safe amount is. So I can't tell a group of women, hey, I need you to drink 2 drinks a day. Another group, I need you to drink 5 groups a day. And this other group, you're not going to drink at all. I can't do that. So what we have to do is we have to look at things that are already happening in the environment. So naturalistic observation is one of them. This is where we just observe behavior as it unfolds in the real world, the natural world as it happens. We can do what's called correlational methods, making measurements to discover the relationship between events. And because we're not actively manipulating who's in what group, we're not doing placebos, it's not experimental. We can also do what's called a case study method. This is an in-depth focus on all aspects of a single person in a clinical setting or a small group of people who have gone through something particularly special. We can also use surveys. So we use questionnaires or surveys to poll large groups of people. So a little bit more on each of these. Naturalistic observations. So Jane Goodall is probably the most famous naturalistic observational researcher. If you don't know who she is my hero. She actually came to FAU in the spring of 2019, and I got to meet her. I have a book signed by her. I'm very excited. But this is Jane Goodall in this picture here. So Jane Goodall, in the 1960s, she was an untrained scientist. She actually was working as a secretary and a waitress before this. She didn't even have a bachelor's degree. She was chosen by a famous anthropologist named Louis Leakey. He's famous because he discovered the Australopithecus africanus skeleton named Lucy in the Oldgai Gorge in, I believe it was Tasmania. And he wanted to see how non-human primates, such as chimpanzees, gorillas, and orangutans, how they were similar or different than humans. So he selected her because of her lack of scientific training and sent her to the Gombe Gorge, or Gombe Stream area. It's a forested area off of Lake Victoria in Africa, and asked her to just observe chimpanzee behavior and report back what she found. And so she went there with her mom, no one else, and they set up a camp. And she eventually got the chimpanzees to trust her, that she wasn't a threat, and she was able to observe them doing their natural behaviors. And a lot of what we know from wild chimpanzee behaviors comes from her research. She was the first to discover the tight familial relationships between chimpanzees, their hierarchical society, so they have like dominant males and submissive males, females, their grooming behaviors, what they eat, how they sleep. And she was actually the one who discovered chimpanzees using tools for the first time. And this is a huge deal. Up until that point, they thought what divided humans from the rest of the animals of the world was our tool use. And so she saw chimpanzees picking up little twigs, taking off side branches and leaves, so they had to manipulate and actually create the tool, not just find something laying around. They would stick it in a termite mound, wait for the termites to pinch onto the stick because it was an intruder, and then carefully pull it out, and then they could eat the termites off of the stick, kind of like something off like a kielbasa skewer or something, and so, or a kebab skewer. And so she observed this, and she sent a letter to Louis Leakey explaining her findings, and he sent back a telegram saying, we either must redefine tool, redefine man, or redefine chimpanzee, essentially saying that we either need to change what we define as a tool to keep chimpanzees out of the club, we need to redefine what chimpanzees are, or we need to redefine who man is because we are the tool users, but now chimpanzees are tool users. So it's a really huge finding, and she's just an absolutely spectacular person, and I encourage you to learn more about her. There's a great documentary about her called Jane you should check out. We can do this with people as well. We can observe people moving around a setting, so how they shop in a grocery store, what they look at, what they touch, what they purchase. But one of the downsides to this is that if we're watching people, they have what's called the observer effect. They actually might change their behavior because they know that they're being observed. If any of you guys had played the old video game Roller Coaster Tycoon, one of the things you could do in that game was you could pick up a person and you could essentially follow them through the park. And it was funny because after a minute or two of doing this, they look over their shoulder, like up to you as like the game player, and they'd be like, I feel like I'm being watched. And that's kind of that observer effect. If you know a teacher is watching you, or if we have, someone from administration come into the classroom and sit in and look around, you're going to change your behavior. You know you're being watched. We also have what's called the observer bias. This is our tendency of the observer themselves to distort our observations or perceptions to match our expectations. And this is something that Jane Goodall was criticized of. She was criticized because she was giving chimpanzees descriptions of all their behaviors as being very humanistic. So jealousy and anger and love and affection, all these things that scientists didn't believe that animals could do at the time. So they were saying that she was distorting her observations to meet her untrained expectations. This is also called in this case, for Jane Goodall, the anthropomorphic error. This is attributing human thoughts and feelings to our animals that we observe. So essentially making them more sophisticated than they actually are. So anthro means human, and pomorphic. So anthropomorphic, we can also have the adultopomorphic error, which is attributing adult thoughts and feelings to children. So it's a fun word. So anthropomorphic error. Correlational method is another really useful tool. So a correlation is an existence of a consistent and systematic relationship between two events, measures, or variables. And all this means is that when one thing changes, another thing changes in kind. And a correlational study, again, is a non-experimental study designed to measure the degree of the relationship, if there is any, between two or more events, measures, or variables. And this is measured using a statistical technique, but the coefficient of correlation is the number we get out of this. This is a statistical index rating from -1 to 1 with 0 in the middle, indicating directionality. So if you look at a number line, -1 is on your left and +1 is on the other side, and how strong someone is to either extreme measures the directionality and the strength of that relationship. So I'm going to give you a couple examples. Okay, so here this is again. So 0 means there's no relationship at all. So how many waffles you ate and your shoe size has really no relationship at all. But a perfect positive relationship means every single time one goes up, the other one goes up exactly the same amount each time. -1 goes the opposite way. It's a perfect negative correlation, so when one goes down, the other goes down. So here are some examples, and these are usually depicted in scatter plots, which is what these things are, the little dots in a graph. So if we look here at the top left, so A, this is a perfect negative correlation. So you could see, an example I like to use for this is the weight of the vehicle and the miles per gallon that the car gets. So a really large car, the very first dot here, the large dot would then represent, or this dot here would represent a very light vehicle that has a really high fuel economy, so it gets a lot of miles per gallon. So like a little smart car, weighs almost nothing, gets really high fuel efficiency. But then as cars weigh more, their fuel efficiency goes down. So, a big Suburban or something, a very big SUV is going to be very heavy, and so therefore its fuel economy is going to be lower. But as you can imagine, there's a lot of differences in how cars are built and how fuel efficient they are, how aerodynamic they are, whether it's a hybrid or not, whatever. So it's not a perfect straight correlation. They actually almost never exist in nature. So maybe the next one, B, is a better relationship with that. So you see you can still see where the line would go, but it's almost, and it's going downward, but it's not perfect. There's a little bit of flexibility in there. So that's a little bit better example. In C, we see a relationship that's almost 0. If you were to try to draw a line through that, you wouldn't know which direction that would be going. So that's a 0 correlation. So again, the waffles and your shoe size, like really, there's no correlation there. If we go down to D, this would be like the hours you've studied to the grade in the class. So if you study almost zero, the first dot, then you're not going to do well in class. But if you study a whole lot, you're going to have a higher grade for most of your classes. But of course, there's some variability, so it's probably a little bit more like something like E. Now, graph F, the one with the little like upside down, a little rainbow shape, that also has a correlation of 0. But if you're looking at that, you're probably thinking, well, there's some sort of relationship going on here. And so we, as scientists, we like to make these scatter plots because while we might run the numbers and 0 comes out, there's still something going on here. It's parabolic. And so we have to actually pay attention to these relationships. So for an example, number of hours per day that you exercise and life expectancy. So if you don't exercise at all, your life expectancy is kind of low. You exercise, a moderate amount and your life expectancy goes up. But at a certain point, you're just putting more wear and tear in your body. So if you exercise, say 10 hours a day, you're probably going to actually have a lower life expectancy, and you'll see that strange little curve going back downward at the end. And so while the relationship, according to a correlation, may look like nothing, it's still important to understand, and you need more advanced statistical practices in order to look at that. So the important thing to understand, though, is correlation does not demonstrate causation. So there might be a correlation between two things. So for example, there's a famous example that there's a correlation between the amount of ice cream sold and the number of murders. You're thinking, what? How do those things relate? Well, it's a third variable. So what actually happens is heat. So the temperature outside. So if it's hotter outside, people are more likely to buy ice cream. If it's hot outside, people are more likely to be outside and kind of irritable, especially if you live in an area without AC all over the place. And so people are more likely to be murdered. I know it's kind of a silly example, but it's a classic one. Also, the number of, what's the old one that I've heard before? It has to do with like the number of cars are related to the number of airplanes. It just has to do with the number of people with income, a high level of income. So people who have disposable income can have cars. People who have disposable income can also fly in airplanes. There's more airplanes. It has nothing to do with cars causing airplanes to occur. Like cars do not breed airplanes. Another case study or method that we can do is called a case study method. So sometimes we cannot, or it's unethical to study some rare events experimentally. I can't cause someone to have severe brain damage in order to study the effects of that brain damage. I can't kill off a group of people's parents to determine how grief in adolescence can cause terrible outcomes for that child. And so we just have to use people who have already experienced that disorder or experienced a rare event. So for example, a school shooting. If a researcher is interested in the effects of a school shooting on the outcomes of people in adulthood or their anxiety levels or something like that, we can't cause a school shooting. We can't make that occur. We have to look at populations who have already experienced that. We're going to be talking about this special case of this guy named Phineas Gage in our next chapter, who had a very, very interesting accident occur. And researchers at the time, and around the 1880s, 1890s, who studied him, and even after his death, have really learned a lot from him. And that's definitely a great example of a case study. We also do a lot of research with people who have like amnesia in psychology. So people who have had parts of their brains removed surgically because of a seizure disorder have then experienced extreme amnesia, so they can't remember their past or they can't make new memories. And researchers have been able to follow up with them and observe them throughout their lives until their death, and have been able to learn a whole lot about the functionality of the brain that way. But again, we can't cause someone to have brain damage, and then to do that for research purposes. We have to have someone who has this sort of thing occur, and then we follow up with them afterwards. And survey methods. So the thing with a survey is, you can't ask everyone in the world to answer your survey. You may try, and the U.S. government actually tries to do this every 10 years. Does anyone know what that's called? The U.S. Census. It's actually going to be happening next in 2020. And so every single person in the United States is going to be asked to fill out or every household is going to be asked to fill out a survey talking about how many people are in their household, what their ages are, what their races, their income levels, their level of education, how many vehicles they own, a whole bunch of different things. And the United States is going to try to get this from every single person in the United States. Now, they get pretty darn close, but they cannot get to 100%. I would guess somewhere between 90 and 95% success rate. So even the United States government, they put billions of dollars behind these, and they still can't get 100% of people. So typically what we have to do is we have to select a smaller sample from the overall population. And we want that sample to be what we call representative. That's a small, randomly selected part of the larger population that accurately reflects the characteristics of the entire population. Now, the population, though, is the entire group of people, of animals or people belonging to that particular category. So we could be looking at all married women or all teenagers, something like that. And we have to be careful about bias samples. These are subparts of a larger population that does not accurately represent the overall characteristics of the population. So there's a good example of a newspaper doing this wrong about 100 years ago. So there was an election you probably have heard of this guy, President Truman. And in that election, it was happening right around the time that telephones were coming into the household. Now, newspapers were still the way that people got their news. And so if you're a newspaper editor, you want to try to predict who won the election so that you can print your newspapers first and have them on the newsstands ready for people to buy, so that as soon as the moment that news breaks, boom, you can make your sales. So there's a couple of different things you can do. You can either print papers with both people, because remember, it takes time to set the typeface and to actually print it. This isn't, just hitting click and letting it go on your website or sending out a tweet. This would take several hours to do. So what they would typically do is they would print a group of each winner. So it was Truman versus this guy named Dewey. Now you know that we didn't have a President Dewey. So they could print both. But that costs a lot of money because you're having to double print and you have to throw away the ones that are incorrect. So that costs a lot. So what the newspaper editor wanted to do was predict who was going to win the election so they could print the right newspaper. So what he did is, or what the newspaper did is, after the election, they started calling people and asking, who did you vote for? And overwhelmingly, they got the answer, I voted for Dewey. So they printed a bunch of newspapers that said, Dewey beats Truman, right across the headline, and printed them all up, and they had them ready to go. But of course, we didn't have a President Dewey, we had a President Truman. Now, I think it was the 1930s or 1940s when this election occurred. Now, who had telephones back then? It was typically rich people, wealthier people, who had the means to have a telephone in their house. But there are more poor people in the country than there were wealthy people in the country. So the number of people that they surveyed were actually disproportionately skewing to Dewey instead of to Truman. And so they actually misprinted the paper. And it's a classic picture of President Truman holding up a newspaper saying Dewey beats Truman across the top, and because of poor sampling methods. They got a biased sample. So you always have to make sure you have a representative sample of that overall population and be very, very careful about that. There's also a bunch of internet surveys. You probably have seen these before. A lot of websites, if you go to purchase something, will ask you for your opinion about how, in a little pop-up, like how the website function was. So web-based surveys are great. They're very cost-effective. They can reach a large group of people, and they're more diverse than college samples. So someone walking around on a college campus to get people to fill out their survey. The problem is that we have a lack of control of who answers and if they gave genuine answers. So our results could be skewed because they just decided to be a goofball and answer our survey with silly answers. One of the tools that researchers use a lot is this program called Amazon Turk. You can actually go online and sign up for this, and marketers and researchers pay people like anywhere between 2 cents and 10 cents to take their survey for them or participate in their study. And so researchers can get like 600 people overnight to take their survey by paying them a nickel each, which is very cost effective for the researchers, and it gets people some pretty good data. But again, you still have the problem of you don't know who's necessarily answering or genuine answers. giving genuine answers, which can be kind of a downside for these types of studies. We also have to be careful about social desirability. So we have to be careful about the type of survey that we're using and making sure that our questions are written properly. So questions can be leading or cause participants to not answer the questions honestly. And so if the questions are leading them into one answer, so if you're on a store's website, like, you know, I'm trying to think of a goofy way to say this, but like, have you seen the amazing quality of our handbags? Because they've said the amazing quality, it makes you think that, oh yeah, wow, that really is an amazing quality stitching on our handbags. So we got to be really careful in the way that we ask questions to make sure we're not leading people down a pathway or to get the answers that we're looking for. We also have to know that people have a tendency to give polite or socially desirable answers when they are doing a survey. So especially if we're asking people about sensitive topics, their perception on race or sexuality, people aren't going to be super forthcoming with their answers if they know that if the survey could come back to bite them. So they may give socially desirable answers, or if they think the people who are going to be looking at the survey are going to want that specific answer. So we have to be very careful in how we ask these questions. All right, so that's the end of this chapter. Chapter 1, I hope you learned a little bit about experimentation and non-experimental methods in this last section. Our next chapter, chapter 2, is on the brain and neuroscience. So I'll see you then.